So, I use Home Assistant all the time to control lights and all kinds of stuff around my house. And part of that setup, I have Home Assistant running in a virtual environment in Proxmox in the basement where it doesn't have access to any real hardware. And because of that, I need a separate node somewhere in the house that has the wireless radios. This is my Z-Wave, my Zigbee networks. And I have a Raspberry Pi whose entire job is to do that thing. So when the SD card on that Raspberry Pi died, I decided I'm going to spend the day rebuilding it from scratch to show you guys how I use a Raspberry Pi as a remote Z-Wave and Zigbee radio for Home Assistant. So if that sounds good to you, then come along on this adventure. So both Z-Wave and Zigbee need special radios like this. This is a TI CC2511, I think. It's the first radio I used for Zigbee. It's not great, but it got me through a couple of years. Now the special radio thing is one of the barriers to running Home Assistant in a virtualized environment. You obviously need the radios to be real hardware. They need to get passed through to your VM or container somehow. And if you have an environment where these containers and VMs can move around, you need to make sure that this is on the right host. At least in the case of Z-Wave 2, Z-Wave keeps the entire network on the stick itself. So you can't just have a second stick and use whatever stick is on the server you're using. You have to have this specific stick. You can back it up, but it's a huge pain to dump the EEPROM out of the stick, and it's one of the reasons I'm not a huge fan of Z-Wave. So anyway, I had this AOTech Z-Stick Gen 5 Plus. This was what I used. This has some problems though, and currently it will short out the 5 volt on the Raspberry Pi because this has some USB violations. So I'm going to switch it out today to a new stick I bought at Silicon Labs. What is this guy? USB 7. So this is a Gen 7 controller. And that's what I'm using today. So I don't know if you guys are familiar with Z-Wave and Zigbee technically. Both of them essentially form a tree topology network between all your end devices and the controller. So for Z-Wave, that controller is a stick, specifically a stick running a chip made by Silicon Labs, because Z-Wave is proprietary to Silicon Labs currently. Z-Wave is relatively well designed. It uses 900 megahertz in the US, 850 in the EU, which is a relatively open frequency, has good propagation at home environments, things like that. Z-Wave is limited to 255 devices, I think, or 254, something like that. It's also, again, not a standard. It's based on proprietary Silicon Labs. But because it's proprietary Silicon Labs and everyone has to use Silicon Labs chipsets, the interoperability is very good. You won't find the device that doesn't interoperate or breaks the network somehow. They will all communicate properly and they will all work. That's not what I can say about
Zigbee.
Here's my Z-Wave stick that I actually use. This guy is the Zig. He just got a better antenna. Nicer stick than the TI one.
Zigbee
is based on IEEE 802.15.4. So you've probably heard about the other IEEEs, 802.11 Wi-Fi, 802.3 wired Ethernet, 802.1 is MAC layer. They use 802.15.4, which is a personal area mesh network. So Z-Wave is essentially an open standard. You can produce devices using Z-Wave without any licensing or using specific chipsets. There are quite a few manufacturers that make Z-Wave chips. This, of course, does mean there are some vendor shenanigans or poor compatibility. I have some hardware from Aquara, for instance, that won't pair through a router. It'll only pair directly to the controller, which really limits the range. One option I have with Zigbee is I could run 2 separate networks on 2 separate Raspberry Pis in 2 areas of the house. The devices won't talk to each other, but they can talk to each other through Home Assistant. And I guess I could have done that for Z-Wave as well, but the Z-Wave mesh in my house has actually been extremely reliable and hasn't had any problems. And that's different from something like Thread, where you can have a Thread border router in more than one location in the house, and all of them are part of the same mesh, and all of them talk to each other magically. Z-Wave and Zigbee don't do that. They're a tree structure with one root, and that one root is how we talk to Home Assistant. So specific hardware in this video, I'm going to use the Silicon Labs Z-Wave controller, the Zigbee Zig. I've got a Raspberry Pi 3, Model B+, the 64-bit. Doesn't really matter what Raspberry Pi you have. Raspberry Pi 2 is fine. I've got this UPS board they got from Waveshare a while ago, so that'll keep it running through power outages that we have a lot of here. These are all USB 2 because there are some problems with USB 3 interfering with 2.4 gigahertz networks like Zigbee. But these guys can just plug in here, and it'll be good to go. Just getting started with Raspberry Pi, I imaged my SD card with Raspberry Pi Imager with the latest version of Raspberry Pi OS Lite 64-bit. Then I booted it up, connected to it over SSH, and disable IPv6 because ain't nobody need that in their network. Oops, I kind of forgot sudo there. So I did the usual apt update, apt upgrade, just to make sure all the packages are up to date. I'm also pulling from my cache server if you want to see my video on deb caches. So with all the basic stuff in the OS running, now I can get to setting up Zwave.js UI and Zigbee to MQTT. These are the two pieces of software that will manage the two networks, Zwave and Zigbee. Both of them need to have a serial port to the dongle. So before I install either one of them, I'm going to figure out what my two serial ports are named. So I do this ls-la dev serial by ID. That gives me two serial devices here. One's called USB 1A86 USB serial IF00. And it says that is TTY USB 0. And then the other one is USB Silicon Labs CP201N USB UART bridge controller, blah, 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 blah. That one is TTY USB 1. So if I need to know in the future, USB 0 is my Zigbee, USB 1 is my Z-Wave, but I actually could just use this whole path here, dev serial by ID, this long thing. Then it will never change if I use the same dongle. If you want to copy and paste commands, I have a guide on my website with the help with this, link down in the description for that. So it includes sections for Zwave.js, the base OS stuff I did, Zigbee to MQTT, and all the other stuff I'm installing in this video. So you can refer to that for the actual syntax of any of the commands. So first off, we're going to download a setup file from node source that'll install Node.js 22. Then we'll actually run that with sudo. So then we install Node.js with apt. Zwave.js UI has a couple different ways you can install it. I chose to install it via Node.js and Node Package Manager. Being a Node.js app, that seems like the most, native way to install it. I prefer to avoid solutions like snap packages, which is another option. I really don't like snap packages. So now that's done, we just tell npm to install Zwave.js UI. I also wrote a systemd unit to run this as a service. I like managing all my processes in systemd. It gives me access to other logs and journal control, things like that. And I can also run them manually if I have to. So anyway, you're free to copy and paste my systemd unit. I'm going to use it. So now that it's up and running, I just went to the IP address of my Pi, port 8091, and we're into Zwave.js. So at this point, Zwave.js is running, but I don't actually have anything configured. So I need to go to Settings, and let's see, what device are we? We are Silicon Labs U. They generate new keys because it's a new network, so I'll pick that. RF region would be USA, and set all this other stuff. So after that's done, I actually don't need the MQTT gateway because I'm just going to be using it for Home Assistant. So here we'll enable the socket. It's going to be in port 3000. We could use DNS discovery, or we could just type it in manually, and let's go. So in Home Assistant, you can just hit add hub, type in the domain name and port 3000. It'll give you something like this. And it even supports adding Z-Wave devices here directly. So now at this point, I got to go around and repair all of my devices because I have a new dongle. If I had the old dongle and it still worked, I wouldn't have to do this. So anyway, let's go do that together. So now that I've found the QR code here, I can go ahead and hit add device, QR code. Come on. So it eventually found it here. It's ready to go. And come into Home Assistant, and I can give it a location. Okay, so excluding and re-including all my Z-Wave devices took way longer than I thought it would. But I'm committed to finishing this thing today. So let's jump into Zigbee. So we again need Node.js. But if you've already installed this for Z-Wave, you're good. Otherwise, I got the commands in the blog. So for this guy, we're going to git, because I'm going to clone the git repo, so we'll install that. So next up, I'm going to create a directory and give it over to my user, in this case Zeus. So this is where I'm going to put Zigbee to MQTT here in opt. So I'm going to clone Zigbee to MQTT into the opt directory, and I'm just going to clone the latest instead of the whole history. So I'm going to run npm ci and npm run build. This is going to build Zigbee to MQTT. And once again, I got a systemd service for this. It's on the blog. Copy, paste it in, system control daemon reload, and enable and start the service. One last thing, it'll fail to start if the serial port's wrong. So we got to go into this configuration.yaml, which is in the data folder, and change this guy to match the port we have. There's also a few other settings you can change here. If you want home assisted discovery, which I do. If you want all your devices to join, which I don't, you can change that from the UI, and the MQTT server authentication. Also, we need to add a front end if we want to run a front end, which I do. And here we are. So we're at port 8080, and it's working. So that whole goal of getting both Zigbee and Z-Wave set up in one day did not quite work out. It's a few days later now. But I have managed to repair all of my Zigbee and my Z-Wave devices. I chose to repair all of my Zigbee devices to a new network, even though I had a backup of the old one, because most of their batteries died anyway, and for some reason, the really cheap Zigbee devices I have lose their pairing information when their battery dies, so I was already going to have to repair most of them anyway. That is a downside of Zigbee. The manufacturer compatibility is not always perfect. The Zigbee Alliance, Zigbee is an open standard, so anyone could implement the standard by reading the documentation and doing it. If you get your product Zigbee certified by the Zigbee Alliance, the CSA, you can put the Zigbee logo on the box. So a lot of manufacturers kind of skip out on that. So Aqara, for example, I have an Aqara temperature sensor here. This thing is a huge pain because I bought like 10 of them because they work well. But the problem I have with them is they won't pair through a Zigbee router, only right to the controller. They don't do a lot of Zigbee things properly. So there's that. I have some sawn-off devices as well. Those are the ones that lose their pairing, which is a huge pain because all my motion sensors now lose their pairing all the time. So you just don't see those kinds of problems in Z-Wave. Every device in Z-Wave has to use the same radio firmware from Silicon Labs. They have to be certified by the Z-Wave Alliance to be on the market. It's just how it is for Z-Wave. If you're into the new Matter and Thread standard, they're a bit in between. So Matter and Thread are both developed by the CSA, which is the same standards body that developed Zigbee. And in order to get a product Matter or Thread certified, you get to put your logo on the box, which is nice, but most manufacturers don't really care about that. The other thing, though, is that certified devices get their own certificate. So every device in Matter does a certificate exchange when it provisions itself out of the network. And if you have a certified device, you can get a certificate signed by the CSA. And so then you won't get a little warning when you try to add it to Apple Home that says this device is untested. So it's kind of like the green checkbox, which I think will keep manufacturers more in line in making compatible products instead of the mess we had in Zigbee. So anyway, do I really have both networks in my house? And I actually have more than just these two. So I have the Z-Wave network you saw me set up today. I have the Zigbee setup from today. I am going to use my older TI dongle to set up a second Zigbee network in my basement because I have some sensors down there that are out of range of the upstairs ones, and they won't talk through routers because they're from Aqara. So we'll have a second Z-Wave to MQTT. I also have a Thread network now, so I'm hoping to set up a second border router for that, so I can have one upstairs and one downstairs to have really good connectivity for Thread as well. I use 433 megahertz still. I made a video on that before in the past. I use Wi-Fi, I use Ethernet, so I got a lot of different communications going on here. So if you have any questions about this video, check the blog post link down in the description. That has all of the commands to execute to run all of these things. So check that first. Feel free to comment in the comments section or email me if you have any problems with that. I can always update the blog much more easily than I can update this video. If you want to chat with me about home automation or home assistant, I have a Discord server as well. I always welcome people there. If you want to give any tips, if you think I've helped you a lot, I have a Ko-fi link down below for that. That's kind of like a Patreon, but it's only a one-time thing. It's not recurring. So those help me out a lot. And as always, I'll see you guys on the next adventure.